In this video, we will try to solve a problem on min function. The question is like this. A consumer has utility function u is equal to minimum of 2x1 plus x2, x1 plus 2x2. x1 and x2 are the two goods. Okay. Her income is, $100 here, and prices of good one is 20 and price of good two is 30. The amount of x1 in the utility maximizing bundle is, the options are 7520. We need to find out the utility maximizing level of good x that our consumer will consume. Okay, so what we are being given, we have this utility function that is u is equal to minimum of 2x1 plus x2 and x1 plus 2 x2. Okay, and what is our budget constraint? Budget constraint is simply price of good one into units of good one plus price of good two times units of good two should be equal to m, and here p1 is being given us as 20, that is 20 x1 plus 30 x2 is equal to 100. Okay, this is our budget constraint. We need to maximize this utility function subject to this budget constraint. Okay, so this is a kind of hybrid utility function. It is the minimum function. Whatever is the minimum among the two arguments will be our utility maximizing quantity here. Okay, now let's first figure out the indifference curve pertaining to this utility function. We know that indifference curve is a combination of all those bundles which give the consumer same level of utility. Okay, so we will keep a utility constant, let us say at a level of 6. Okay, so we will draw this indifference curve at the utility level of 6 first. Okay, then our task is to plot this minimum function on xy space, sorry, in this case x1 x2 space. Okay, so let's first draw the graph also. So let us say this is our graph. We have units x1 on this axis and x2 on this axis. Okay, so first we will try to draw the indifference curve, and then we will see the optimal quantity of x1 that our consumer will be consuming. Okay, so first step in solving this kind of question is, there can be three cases here. Obviously first we will draw the indifference curve of this argument and this argument at a utility level of 6. Okay, so for that, what will we do first? First let's take the case. We will have the three cases here. That is, first case will be when both these two arguments will be same. That means 2x1 plus x2 is equal to x1 plus 2x2. In this case, when we solve this, 2x1 minus x1 is x1. x1 is equal to x2. Okay, when you solve, you will get this. So if we plot this, x1 is equal to x2, it will look like this. Okay, we have a 45-degree line where x1 is equal to x2. Okay, next case can be the case where 2x1 plus x2 is less than x1 plus 2x2. Okay, when we solve this inequality, transposing this here, so we will get x1 is less than x2. Okay, so if this is the case, what will be our utility. So we have fixed the utility at 6, and this argument is less than this argument, and we know in case of min function whatever is minimum between the brackets is our utility. So in this case our utility will be equal to, since this argument is less, okay, minimum of these two is and this very first argument, so our utility will be equal to, that is 2x1 plus x2, and let us solve it for the utility level of 6. Okay, so we have here two conditions. First we draw the indifference curve 2x1 plus x2 at a utility level of 6. So let's try to plot this out, and also we should satisfy this condition, x1 should be less than x2. Okay, so if we solve this, if I put first let us say x1 is equal to 0. If I put x1 is equal to 0, x2 will be equal to 6. Similarly, if I put x2 is equal to 0, x1 will be equal to 6 divided by 2, which is equal to 3. I hope you know how do we plot this. First we put first term, first variable equal to 0, solve for other variable, and then take second derivative, second variable 0, and solve for first variable. Okay, so here we can see our indifference curve will have, on x we have 6, and sorry, on x2 we have 6, and on x1 we have 3. Okay, so let's try to draw here. So let us say this is 2, this is 4, this is 6. Okay, similarly we have here 2, here we have 4, and here we have 6. Okay, so solving these two, we have 6 on x2 this point, and 3 on x1, let us say it is here. So our indifference curve will look like this. Okay, this red one. So 2x1 plus x2 should be equal to 6, and x1 is less than x2. Okay, so if we take any point below this black curve, here x1 is greater than x2. Okay, if we put let us say this point, you can see here it is 2, here it is only 1. Obviously x1 is greater than x2, but our indifference curve should lie in the region where x1 is less than x2. Here x1 is greater than x2, so this red shaped line will be not the part of our indifference curve. So our indifference curve will be only up to this line. Okay, and by the way, what is the slope? So let me first write it to this. So what is the slope here? Here it is 3. Okay, what is then slope? Slope of this red line is simply, so we know the slope is rise our run. Okay, rise our run. Okay, so we have from 0 to 6, so 6 upon 3, which means the slope of this red line is also 2. Okay, so let me write it here. So we got the slope of this red line as 2. Also slope in absolute values is equal to 2. Now let me rub this out. Another case can be, the case third can be, when 2x1 plus x2 is greater than x1 plus 2x2. Okay, which implies when you solve this, it will be the case when our x1 is greater than x2. Okay, and if this is the case, obviously this argument is less than this argument. That means our utility will be equal to this, x1 plus 2x2, and we have fixed the utility level of 6 here. Okay, now plotting this variant difference karo, let us put x1 is equal to 0, which will give us x2 is equal to, so 6 upon 2 is 3. Put x2 is equal to 0, our x1 will be equal to 6 in this case. Okay, so what will be our indifference curve in this case? So our indifference curve will be, so we have x2 is equal to 3, x2 is equal to 3, and x1 is equal to 6. So let us say here it is 3. So Shahmat, okay, so we have like this the indifference curve. But we have two conditions here. X1 should be greater than x2. In this case, in this region, you can see x1 will be less than x2. Okay, if we take this very number, okay, 3 here, x2 is 3, x1 is 0. So up to this point, our x1 is greater than x2. Okay, so you can easily see here, first our x1 should be greater than x2. Sorry, I have just messed with this. Actually, our indifference curve will be in this part, because here the case is where x1 is greater than x2, and in this part x1 is less than x2. Okay, taking any point, let us say this point, here x2 is 2 and x1 is only 1. Obviously this is the part where x1 is less than x2, but we should have x1 greater than x2. So this whole green line will denote our the area where x1 is greater than x2, and this area is actually the opposite, x1 is less than x2. So this will be not the part of our indifference curve. Okay, so also the slope we can calculate easily. So here we have 3, slope is equal to rise, our run. So we have 3 divided by 6. So in this case our slope of this line is slope is equal to half, 1 upon 2. Okay, in absolute terms, let me write it clearly, 1 upon 2. Okay, now we need to compare our, and on this line we have x1 is equal to x2. Okay, so we have three regions here. This region is the region where x1 is greater than x2. This region is where x1 is less than x2. Okay, when x1 is less than x2, this red line will be our indifference curve. When x1 is greater than x2, this blue line will, sorry, this green line will be our indifference curve here. Okay, now let's see what is the slope of our budget line. Now what is the slope of our budget line? So this is our budget line. The slope of this budget line will be equal to 2 upon 3. Okay, so slope of budget line is equal to price p1 upon p2. Okay, which comes out to be 2 upon 3, that is 20 upon 30 is 2 upon 3. Okay, now where will be our optimal bundle lie? There can be number of cases. First case can be like this. First case will be when p1 upon p2 is less than, we have 2 here, obviously then we have 1 upon 2 here. When the slope of budget line is small compared to other slopes, compared to this line and this line. That means when p1 upon p2 is less than, in this case, 1 upon 2. Okay, if this is the case, then our budget line will be flattest and consumer will consume at this point. Okay, if p1 upon p2 is greater than, we have 2 here, so if the slope of the budget line is steepest, okay, in this case consumer will consume all units of on this x2. Okay, and another case can be, so if this is the condition, we have flattest budget line among these 1 and 2 lines, and if this is the case, we have the steepest budget line. In this case consumer will consume all units, all of x1. In this case consumer will consume all of x2. Now what is our budget line, sorry, what is the slope of budget line? So let us take another case. I forgot to write here. Another case can be when p1 upon p2 is less than 2 but greater than 1 upon 2. Okay, if this is the case, and which actually is in our question, okay, then our budget line will touch at the kink. Okay, so budget line will pass through kink in this case, and here you can see, let me write it here. We can see here we have 1 upon 2, okay, is less than, so p1 upon p2 is 2 upon 3, okay, but it is less than 2. Okay, when this is the case, and which is actually the case here, our budget line will touch this indifference curve at the point of kink. Okay, so we can have another, let me draw here another for the sake of simplicity. Okay, so in this case what will be our budget line? So budget line will pass through the kink like this. Okay, this is our budget line. This is our budget line, because this condition is being satisfied. In this case, when this is the case, what will happen? Consumer will consume, we will have interior solution. And what will be the solution of our problem here? So let me see if I have any space here. So in this case, what will our consumer consume? Since x1 is equal to x2, just plug this value back in our budget line, budget constraint. Okay, if we put this value here, that means we have 20 x1, so we have x1 is equal to x2, then we have 30 x2. In place of x2 I will write again x1 plus 30 x1 is equal to 100, which implies through the panza 50 x1 is equal to 100, which means x1 is equal to, so where should I write it? So let me write it here. Yes, I have the space. That means x1 will be equal to 100 divided by 50 is equal to 2. So consumer will consume 2 units. That means at this point, okay, at this point consumer will be consuming 2 units of x1 and 2 units of x2. Okay, so don't confuse with these numbers. They were only being drawn here to draw the indifference curve. Okay, so at optimal, consumer will consume 2 units of good x1 and 2 units of good x2. Okay, so the correct option to this question should be this option. Okay, so this is it. How do we solve this kind of utility function, min function? Okay, first we plot the indifference curve using these arguments which are in the brackets, and then we find the optimal combination. Okay, so I hope I make myself clear in this video. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.